Good morning, grade 7. Today we will continue lesson 6.1 and we will discuss the second part, which is talking about highest or prime factors of numbers. We studied before how we can simplify the like terms and how we can distribute the number over the parentheses. So let me remind you first what we already studied before. We studied in the first part how we can simplify the like term like 2x plus 3x minus 4x. So this is a like term and we want to simplify. So all of them have x, x, x. Then we have to add. You can add them directly by using your mind to calculate it, or you can collect all the coefficient together, which is the number before the variable, like 2 plus 3 minus 4, and then close the parentheses and don't forget to put the variable. And then it will be 1x, and we don't want to write 1x, so the answer it will be only x. And so on. The question maybe have only one variable, so we will add all of them directly. Maybe we have more than one variable, so we can divide them into groups. Each group, it will contain all the variables which they are like term. Second, we studied how we can distribute a number over a parentheses. Like if you have 3 and then a parentheses, 2x minus 5. Then, how we are going to expand this number? We will distribute the number over the parentheses by multiplication. So we have, this is the first one, 2 times 3, and then we have the second one, 2 times negative 5. So the answer, it will be 2 times 3, it will be equal 6x minus 3 times 5 equal 15. So this is how we can simplify a number before the parentheses, and this is what we already studied in the first part of lesson 6.1. Let me check with you another question. It could be 3x minus 4y minus 3x plus 5y. How we can simplify this expression? We will start first to distribute, and don't forget that x, you have 1. The coefficient before x here is 1, but we didn't write it because we simplified. Then it will be 3 times x, this is the first one, 3 times 1, and then 3 times negative 4. Second, it will be negative 2 times 3, and then negative 2 times 5. Now we will start to write the answer. 3 times 1, it will be 3x. 3 times negative 4, it will be negative 12y. Minus 2 times 3, it will be negative 6x. Negative 2 times 5, it will be negative 10y. Now, we didn't finish because we have 2 different variables in the question. So we have to simplify them, and we will distribute them in 2 parentheses. And don't forget that you will separate between the 2 parentheses by the sign plus, because minus, it will change all the numbers which it will comes after it. Then we will put the like term together like 3x minus 6x. And then we will move to the second group, which is negative 4y minus 10y. Then we will close the parentheses. After that, we will simplify. Then I have Now 3, sorry, we will back again. So we said that we will distribute, so it will be 3x minus 12y minus 6x minus 10y. Next, we will distribute them in a parentheses, the like term together. So we have 3x minus 6x, and then we will close the parentheses. We will separate the parentheses by the sign plus, and then we will put negative 6x, and then negative 10y together. Then we will close the parentheses. 3 minus 6, it will be negative 3x, and negative 6 minus 10, it will be negative 16y. And we are going to stop till this point because we can't add x and y because this is unlike term. So this is the part which we studied in the first part for lesson 6.1, how we will distribute a number over the parentheses, how we will add and subtract a like term to simplify algebraic expressions. What else we have in this lesson? We have two prime factors of numbers. We first need to look at how to break numbers down into their lowest prime factors. For example, the prime factors like 2, 3, 5, 7, 11, 13, 17, and so on. And these are the numbers which we cannot divisible by any number except itself or 1. So the easiest way to do this to make a factor 3 where the prime numbers factors end up as the outer leaves of our trees. For example, if you have 12 and we want to make a prime factors for this 12, so we are going to make a factor 3, then we can say that 12 equal 2 times 6. Then 6, this one is not a prime, so we have to continue. So it will be 2 times 3. Now we stopped, so we have 12, the prime factors of 12, it will be 2 and 2 and 3. Then we will move to the next part. If I have a factor, if I want to find a prime factor between 16 and 9, what we have to do? We will start with 16, so it will be 2 and 8, and then 8, it will be 2 times 4, and then 4, it will be 2 and 2. We will take all the outer leaves from the tree. It will be 2 and 2 and 2 and 2. Then I'm going to express them or to explain them like 16 equals 2 times 2 times 2 times 2. By the same way, we can use with 9. By the same way, we can use with 6. Why? Because we want to solve a question like this. Then, to explain, as I said before, 2 and then a parentheses a plus 6. So we will distribute 2 times a, it will be 2a, 2 times 6, it will be equal 12. But now, to create factor form, we work backwards by breaking down and factorizing and expanded answer back into the original brackets form. Like what? If I will start the question and I will give you 2a plus 12. So we want to know the original. It was what? The backwards for this expressions. So we will use 2. We will take 2 as a common. Then if you look at up here, it was 2 and then a plus 6. So we will use the opposite operation now. I'm going to give you this expression, which is 2a plus 12. And then I'm looking for how it was at the beginning when you will use a common factor. Then, to factorize into brackets form, follow these steps. Break numbers into their lowest prime factors, expand out fully all powers exponents terms, identify the common factor, and then write the factors form as common factors leftover items. Put final answer into simplest form, whole numbers, and so on. We will start with this example form. 6m plus 9. So we have to look at the numbers here in both two questions, in both two parts. It's an algebraic expressions consists of two terms, and the first term is 6m and the second term is 9. Then we will select now, we will choose the numbers, which is 6 and 9. What we have to do? We have to do factor 3 to find the prime factorization for each one. Then we will think about 6. 6, 2 times 3. And what about 9? 3 times 3. And then we will start to expand them. 6 equal 2 times 3 times m plus 9, it's 3 and 3. Don't forget to put the variable. Then, now we have to search about the numbers which we repeated between both. Then if we look at the numbers here, we will note that I have 2, 3 in the first one, and I have 3 in the second one, right? So we are going to nominate it. We are going to take it to pull it down. It's up to you. And then we will put 3. Now, what is the rest? It seems like you already canceled 3. Now, take away 3 out. I don't have it anymore. Okay, but I didn't cancel it. I put it out as a prime factorization. Sorry, as a highest common factor. Now, this is 2. The remainder is 2 and m, so it will be 2m, and then I have 3. 2 times m, it will be 2m, and then 3. So it will be the right answer for the question. So if we want to answer the question by taking the highest common factor, we will use the factor 3 first to write the numbers in simplest form with the prime factorizations. Second, we will search about the common between the two numbers. Third, we will simplify the expression. Let me give you another question. In this question, I have 4w minus 2. What we have to do, 4 and 2. Then we will make the factor 3. So this is 4, it will be 2 and 2. This is 2, it will be 2 times 1. Then we will expand. I have 2 times w minus 2 times 1. Now, which number is repeating between both? I have 2 and 2. I will put it out, and then I will collect the remainder. So the first one was 2w, and then minus 1. Then the expression, it will be 2 out, so this is the common factor, and then the remainder inside the parentheses, it will be 2w minus 1. What about if I have a question like this? 12ab plus 16bv. In this question, we are going to make exactly like the previous question, but we have to note here in this question that we have a variable 2 is repeating, which is b and b, right? So we will use the normal method, but we will select already the numbers with the variable b. And we can use multiplication table directly. 12 and 16, both of two numbers can be divisible by how many? 12 and 16. They could be divisible by 2, they could be divisible by 4. Then we are going to take the highest one. So this is, maybe it will be more faster like prime factorizations, but it depends on, you will find the multiplication table directly. If you can't find it directly, then you will back to the way with the prime factorizations. Also, I can remind you a method you studied in grade 4 and grade 5, which is we can make prime factorization by this way for the both two numbers. But you have to note that you will use the prime factorizations. You will divide it by only prime numbers, like 12 divided by 2, it will be equal 6. And then divided by 2, it will be equal 3. And then divided by 3, it will be equal 1. Second, I have 16 divided by 2, it will be equal 8, divided by 2, it will be equal 4, divided by 2, sorry, divided by 2 equals 2, divided by 2 equals 1, right? It's not allowed to put here 4 or 10 or 8. All the numbers, they should be prime numbers. Now we can collect the numbers which is repeating between the both two columns. So I have in the first one, I have here 2, and the opposite side I have 2. What else we have? We have one more 2 and 2, right? And that's it. 3, we don't have partner. 2, we don't have partner. Then 2 times 2, it will be equal 4. So instead of using the factor tree, you can use this method, the column factorizations. Then you will use the prime numbers, and don't forget, and then it will be 2 times 2 equals 4, and sorry, 2 and from both two columns. So I have 2 times 2, it will be equal 4. So directly I have 4. I'm going to put it out. And then B and B, so I will put B out. And then I will open the parentheses to collect the remainder. Then 12AB divided by 4, it will be 3. And I will cancel B with B, so the remainder, it will be only equal A plus 16 divided by 4, it will be equal 4. And we will cancel B because B divided by B equal 1. And then I have V. So this is how we can use prime factorizations and common factors to simplify the expressions. See you in the next video, inshallah. Best of luck to all of you.